Model Test 3, Listening Section.
The listening section tests your ability to understand spoken English that is typical of interactions and academic speech on college campuses. During the test, you will respond to conversations and lectures. This is the long format for the listening section. On the long format, you will respond to 3 conversations and 6 lectures. After each listening passage, you will answer 5 to 6 questions about it. Only 2 conversations and 4 lectures will be graded. The other conversation and lectures are part of an experimental section for future tests. Because you will not know which conversations and lectures will be graded, you must try to do your best on all of them. You will hear each conversation or lecture one time. You may take notes while you listen, but notes are not graded. You may use your notes to answer the questions. Choose the best answer for multiple choice questions. Follow the directions on the page or on the screen for computer-assisted questions. Click on Next and OK to go to the next question. You cannot return to previous questions. You have 25 to 30 minutes to answer all of the questions. A clock on the screen will show you how much time you have to complete your answers for the section. The clock does not count the time you are listening to the conversations and lectures.
Listening 1, Students on Campus.
Listen to part of a conversation on campus between 2 students.
I wish I was sure about my future as you seem to be. I really don't know what I want to do after I graduate.
Well, have you talked with a counselor over at the Office of Career Development?
No. I talked to my academic advisor, though.
Well, that's good. But it's really better to see someone who specializes in helping people make career decisions. You see, an academic advisor is there to help you work out your academic program. You know, figure out what your major is going to be and which courses to take and all that. But a career counselor has a lot of experience and resources to help you decide what you want to do in the work world.
Did you see a career counselor?
I sure did, last semester. I didn't even know what I'd be good at, for a career, I mean. So I made an appointment at the Office of Career Development, and I talked with a counselor.
Do you remember who it was?
Sure, it was Ruth Jackson.
Oh, but since I'm interested in careers for math majors, probably I should see someone else. Not
really. Any of the counselors can help you. Look, first, I took some aptitude tests and something called I think it was called a career inventory. Anyway, I took several tests, and then the counselor gave me some ideas about different careers. I even went to some group sessions with some other students for a few weeks. Mrs. Jackson was the group leader, so, that's how I met her, and then I just sort of naturally started making my appointments with her when I needed some advice.
It sounds like it took a lot of time. I'm so busy already.
Well, it did take time. Probably 3 hours for the tests, and I think I went to maybe 4 group sessions, and then I saw Ruth a couple of times. I guess about 9 or 10 hours, probably. But it was worth it.
So, is that why you decided to go into library science? Because of the tests and everything?
In part, but mostly it was because of the internship. You see, I also got my internship through the Office of Career Development, and when I was working as an intern in the public library, it all sort of came together for me. I really liked what I was doing, and I realized that I didn't want the internship to end.
And you get paid for working there in the library too, don't you?
I get paid, and I get credit toward my degree. But even better, I have a job offer from the library where I'm doing my internship.
Wow. Are you going to take it?
I think so. I have to let them know next week. If I do take the job, I'll have to go to graduate school to get a degree in library science. But I can do that part-time while I'm working, and I'd thought about graduate school anyway. So I'm leaning toward taking the job.
That's great, Anne. I'm glad for you. So, I guess I'd better make an appointment with Ruth Jackson. Maybe she can find me an internship.
Maybe.
1. What are the students mainly discussing? 2. What is the man's problem? 3. Why does the woman tell the man about her experience? 4. What is the woman's attitude toward her internship? 5. What will the man probably do?
Listening 2. Sociology class.
Listen to part of a lecture in a sociology class.
Social influence involves the changes in behavior influenced by the actions of other people. Social influence can come about for a variety of reasons, on a continuum from mere suggestion to, in the more severe form, well, to torture. How does social influence work? Well, first, we must become aware of a difference between ourselves and the values or behaviors of other people. There are a great many studies of social influence that demonstrate how the presence of others can cause us to change our attitudes or actions. Studies show that people eat more when dining with others than, I'm talking about dining out here, so they eat more in the company of others than they do when they're alone. They also run faster when others are running with them. There's even some interesting research on social influence among animals with similar results to those of human studies. Probably one of the most interesting aspects of social influence is the pressure for conformity. Conformity is a process by which an individual's opinion or behavior moves toward the norms of the group. In a classic study by Solomon Asch, 7 people were shown cards with 3 lines drawn on them. Here's an example. So, they were shown the lines, and then they were asked to select the line among the 3 that matched the standard line. Here's the standard. So, there's no question as to the comparison. This has to be easy, right? Wrong. You see, Asch enlisted the cooperation of 6 of the 7 participants in the experiment. On the first card, the 6 respond correctly. They identify the lines of the same length. So the 7th person, who is the only real subject in the experiment, well, the 7th person answers correctly, in agreement with the others. But on the next card, 4 of the cooperating participants choose an incorrect answer, but they're in agreement. So the problem for the subject is whether to conform to the opinion of the peer group, even though the answer is in conflict with the answer that the subject knows to be correct. So, what do you think happened? Well, subjects who were tested alone made errors in answers fewer than 1% of the time. This was the control group. But of those tested in groups of 7, 75% yielded at least once to conform to a group answer that was clearly incorrect. And, on average, subjects conformed to the group in about 37% of the critical trials. This means that they were bringing their behavior into agreement with group norms, in spite of what they were seeing. Later, Asch manipulated the size of the control group, the experimental group, to see whether group size would affect pressure, and it did. But probably less than you might expect. Groups of 4 demonstrated about the same results as groups of 8. Interestingly enough, a unanimous agreement by the group was more important than the number. In other words, a unanimous opinion by 3 exerted more pressure to conform than a majority of 7 with a dissenting opinion in a group of 8. Similar experiments have been performed in various countries among diverse cultural groups with comparable results. Of course, people in cultures that emphasize group cooperation tended to be more willing to conform, But remember that many of the original studies were done in the United States, where there's a high value placed on individualism. In an interesting variation on the study, Abrams found that conformity is especially strong when the group is selected from among those people that the subject clearly identifies with, either because they have characteristics in common or they know each other and interact in a peer group outside of the experimental situation. So what does all of this mean in the real world? Well, since group members can influence one another to conform to the opinion of the group decisions of a group may be called into question. What about decisions by political committees or parliaments? What about juries who are charged with convicting or acquitting an accused defendant? Clearly, social influence will play a part in these critical group decisions. Also interesting is the fact that after a decision is made by a group, there's a tendency to solidify. And by that I mean that the group becomes even more convinced of the validity of the group opinion. This may happen because individual group members who strongly support the group tend to be more popular with the group members.
6. What is the main topic of the lecture? Seven. According to the professor, what two results were reported in the Ash and Abrams studies? Eight. Listen again to part of the lecture and then answer the following question.
Later, Ash manipulated the size of the control group. The experimental group, to see whether group size would affect pressure, and it did. But probably less than you might expect.
Why does the professor say this?
The experimental group.
Nine. What generally happens after a group makes a decision? Ten. Based on information in the lecture, indicate whether the statements describe the Ash study. For each sentence, click in the yes or no column. 11. What is the professor's attitude about the studies on social influence?
Listening 3. Art History Class.
Listen to part of a lecture in an art history class.
We know that the Chinese had been aware of basic photographic principles as early as the 5th century BC, and Leonardo da Vinci experimented with a darkroom in the 1500s. But it was a number of discoveries in chemistry during the 18th century that accelerated the development of modern photography. The discovery that silver salts were light-sensitive led to experimentation with images of light on a surface that had been coated with silver. Often glass was used in the early images, but the problem was that these images were ephemeral, fading after only a short time. Some of the chemists who worked with them called them fairy pictures and considered them that they were only momentary creations, that they'd disappear. Okay, how to fix the image permanently was one of the most important challenges of the early photographer-chemists. In France, in about 1820, Nicéphore Niepce discovered a method for fixing the image after a long exposure time, probably 8 hours. So, although his work was considered interesting, it was largely dismissed as impractical. Nevertheless, one of his associates, Louis Daguerre, managed to find a way to reduce the exposure time to less than 20 minutes. So the story goes, in 1835, Daguerre was experimenting with some exposed plates, and he put a couple of them into his chemical cupboard. So a few days later, he opened the cupboard, and to his surprise, the latent images on the plates had developed. At first, he couldn't figure out why, but eventually, he concluded that this must have occurred as a result of mercury vapor from a broken thermometer that was also enclosed in the cupboard. Supposedly, from this fortunate accident, he was able to invent a process for developing latent images on exposed plates. The process itself was somewhat complicated. First, he exposed copper plates to iodine, which released fumes of light-sensitive silver iodide. These copper plates were used to capture the image. And by the way, they had to be used almost immediately after their exposure to the iodine. So the image on the plate was then exposed to light for 10 to 20 minutes. The plate was developed over mercury, heated to about 75 degrees centigrade, which that caused the mercury to amalgamate with the silver. Now here's the ingenious part. He then fixed the image in a warm solution of common salt, but later he began using sodium sulfite. Anyway, after he rinsed the plate in hot distilled water, a white image was left permanently on the plate, and the quality was really quite amazing. But the process had its limitations. First, the images couldn't be reproduced, so each one was a unique piece, and that greatly increased the cost of photography. Second, the image was reversed, so the subjects would actually see themselves as though they were looking in a mirror, although in the case of portraits, the fact that people were accustomed to seeing themselves in a mirror made this problem less urgent than some of the others. Nevertheless, some photographers did point their cameras at a mirrored reflection of the image that they wanted to capture so that the reflection would be reversed and a true image could be produced. Okay. Third, the chemicals and the fumes that they released were highly toxic, so photography was a very dangerous occupation. Fourth, the surface of the image was extremely fragile and had to be protected, often under glass, so they didn't disintegrate from handling. The beautiful cases that were made to hold the early images became popular not only for aesthetic purposes, but also for very practical reasons. And finally, although the exposure time had been radically reduced, it was still inconveniently long, at 20 minutes, especially for portraits, since people would have to sit still in the sun for that length of time. Elaborate headrests were constructed to keep the subjects from moving so that the image wouldn't be ruined, and many people simply didn't want to endure the discomfort. But by the mid-1800s, improvements in chemistry and optics had resolved most of these issues. Bromide as well as iodine sensitized the plates, and some photographers were even using chlorine in an effort to decrease exposure time. The portrait lens was also improved by reducing the size of the opening and limiting the amount of light that could enter, so the exposure time was about 20 seconds instead of 20 minutes. And negative film had been introduced in in England, and negatives permitted the production of multiple copies from a single image. So, photography was on its way to becoming a popular profession and pastime.
12. What is the main topic of this lecture? (13) According to the professor, what two limitations were noted in Daguerre's process for developing and fixing latent images? (14) Listen again to part of the lecture, and then answer the following question.
At first he couldn't figure out why, but eventually he concluded that this must have occurred as a result of mercury vapor from a broken thermometer that was also enclosed in the cupboard. Supposedly, from this fortunate accident, he was able to invent a process for developing latent images on exposed plates.
Why does the professor say this?
Supposedly, from this fortunate accident, he was able to invent a process for developing latent images on exposed plates.
"15. What substance was first used to fix the images? 16. What can we assume about photographers in the 1800s? 17. In what order does the professor explain photographic principles?
Listening 4. Admissions Office.
Listen to part of a conversation between a student and an admissions assistant.
Excuse me, but the secretary referred me to your office.
Yes?
I'm a new student. Well, actually, I'm not enrolled yet, but I'm trying to get all my admissions applications turned in today.
What's your name?
Robert Franklin?
Middle initial?
T.
Oh, I see. Wait a minute, and we'll find out what you have to do. Well, according to the records here, you have your admissions form, a financial aid application, 3 letters of recommendation, transcripts from regional college. So that's everything you need except a transcript from county community college.
That's what I thought. You see, I took a couple of courses there during the summer because it's close to my parents' house. Anyway, almost all of my first 2 years is from regional college, and that's where I'm transferring from. In fact, the credit for the community college courses appears on the transcript from regional college as transfer credit, but it doesn't show my final grades in the courses.
Oh, and you haven't been able to register for your courses here at State University because the computer shows that you're missing some of your application materials. Is that it?
Exactly. What I was wondering is whether you have, like, a policy for this kind of situation, so I could go ahead and register for this first semester while we wait for the transcript to get here. It should be here now. I requested it the same time that I requested a transcript from regional college, but they're just slow at county community.
That happens sometimes. Do you have a copy of your transcript from county community college?
Yes, I do. It's right here. Of course, it isn't an official copy. It's stamped unofficial copy.
But I can use this one until the official copy gets here. Here's the best way to handle this. We can give you a provisional admission. That means that you're admitted contingent upon the receipt of your official transcript. That'll allow you to register for your courses this semester. When County Community College sends us your official transcript, then I can change your status from provisional admission to regular admission.
Oh, that's great.
Is this the only copy you have of your transcript?
No, I have another one.
Good. Then I'll just keep this in your file.
Okay.
Now the only problem is you can't register for next semester without regular admission status. And you need the official transcript for me to do that. So you still need to keep after them to get everything sent to us as soon as possible.
Right. Well, I'll do that. But at least I have some time to get it done. What do I need to do now? To get registered, I mean.
Just wait here while I enter everything into the computer. And then you can take a copy of your provisional admission along with you to the office for transfer students. They'll assign you an advisor and help you get registered later today.
18. Why does the student go to the admissions office? 19. What is missing from the student's file? (20) Listen again to part of the conversation, and then answer the following question.
Oh, and you haven't been able to register for your courses here at State University because the computer shows that you're missing some of your application materials. Is that it?
Why does the woman say this?
Is that it?
(21) What does the woman suggest that the man do? (22) What will the student most probably do now?
Listening 5. Anthropology class.
Listen to part of a lecture in an anthropology class.
The concepts of power and authority are related, but they're not the same. Power is the ability to exercise influence and control over others, and this can be observed on every level of society, from, the relationships within a family to the relationships among nations. Power is usually structured by customs and social institutions or laws, and tends to be exerted by persuasive arguments or coercion or even brute force. In general, groups with the greatest resources tend to have the advantage in power struggles. So, is power always legitimate? Is it viewed by members of society as justified? Well, no. Power can be realized by individuals or groups, even when it involves the resistance of others, as long as they're in a position to impose their will. But what about power that's accepted by members of society as right and just, that is, legitimate power? Now we're talking about authority, and that's what I want to focus on today. Okay. When individuals or institutions possess authority, they have a recognized and established right to determine policies with the acceptance of those over whom they exercise control. Max Weber, the German classical sociologist, proposed 3 types of authority in society: traditional, charismatic, and rational or legal authority. In all 3 types, he acknowledged the right of those in positions of power to lead, with the consent of the governed. So, how did Weber differentiate among the 3 types of authority? Well, he divided them according to how the right to lead and the duty to follow are interpreted. In traditional authority, power resides in customs and conventions that provide certain people or groups with legitimate power in their societies, often their origins found in sacred traditions. The example that most often comes to mind is a monarchy in which kings or queens rule by birthright, not because of any particular quality of leadership or political election, just because they have a claim to authority based on traditional acceptance of their position, and in some cases their unique relationship with and responsibility in religious practices. The royal families in Europe or the emperors in Asia come to mind as examples of traditional authority. Okay, this contrasts sharply with charismatic authority, which is derived because of personal attributes that inspire admiration, loyalty, and even devotion. Leaders who exercise this type of authority may be the founders of religious movements or political parties, but it's not their traditional right to lead. What's important here is that their followers are mobilized more by the force of the leader's personality than by the tradition or the law. So, when we think of charismatic leaders in the United States, perhaps John Kennedy would be an example, because he was able to project a youthful and energetic image that people were proud to identify with. Or, if you prefer Republicans, you may argue that Ronald Reagan was able to exercise authority by virtue of his charismatic appeal. In any case, going back to Weber, to qualify for charismatic authority, a leader must be able to enlist others in the service of a cause that transforms the social structure in some way, which leaves us with legal rational authority, or power that's legitimized by rules, laws, and procedures. In such a system, leaders gain authority not by traditional birthrights or by charismatic appeal, but rather because they're elected or appointed in accordance with the law, and powers delegated to layers of officials who owe their allegiance to the principles that are agreed upon rationally, and because they accept the ideal that the law's supreme. In a legal, rational society, people accept the legitimacy of authority as a government of laws, not of leaders. So, an example of this type of authority might be a president, like Richard Nixon, who was threatened with impeachment because he was perceived as not governing within the law. Some sociologists have postulated that the three types of authority represent stages of evolution in society, that pre-industrial societies tend to respect traditional authority. But as societies move into an industrial age, the importance of tradition wanes in favor of charismatic authority, with a natural rise of charismatic leaders. Then, as the modern era evolves, the rational legal authority embodied by rules and regulations replaces the loyalty to leaders in favor of a respect for law. Of course, other sociologists argue that in practice, authority may be represented by a combination of several of these ideal types at any one time.
23. What is the main purpose of this lecture? (24) Why does the professor mention Kennedy and Reagan? 25. According to the professor, what two factors are associated with charismatic authority? 26. Listen again to part of the lecture and then answer the following question.
But what about power that's accepted by members of society as right and just, that is, legitimate power? Now we're talking about authority, and that's what I want to focus on today.
Why does the professor say this?
But what about power that's accepted by members of society as right and just, that is, legitimate power?
(27) In an evolutionary model, how is rational legal authority viewed? 28. What does the professor imply about the three types of authority?
Listening 6, Geology Class.
Listen to part of a lecture in a geology class.
The original source of energy is what? The sun, Then plants use the sun's energy during photosynthesis to convert water and carbon dioxide into sugar and oxygen. And they store the energy in the chemicals that the plant produces. When animals eat plants, the energy is transferred to their bodies. So then the plants and animals die and decay, and they sink to the bottom of the sea or disintegrate into the soil, and then they're covered by more and more sediment as rivers deposit mud and sand into the sea, or the seas advance and retreat. Of course, it's a very gradual process, one that takes place over, millions of years. But finally, the organic material begins to transform into the hydrocarbons, and the hydrocarbons eventually become oil and gas deposits. So, how does this happen? Well, at first, the oil and gas are mixed with sand and sediment, but as the layers on top increase, then so does the pressure. And under pressure, mixtures of oil and sand and water, they seep down through the layers of porous rock. That's usually sandstone or limestone. So they sink down until they reach a layer of non-porous rock, and that's where they pool because they can't pass through the non-porous rock. Okay, sometimes there are breaks in the layers of rocks, and the breaks allow oil and gas to bubble up, and eventually they reach the surface of the earth again. So when this happens, the gas and some oil evaporate into the air, but they leave a sticky black tar that appears in pools or pits on the surface. But most crude oil is found in underground formations, which we call traps. So today I want to talk about the major types of oil traps. In all the different types of traps, the oil collects in porous rocks along with gas and water. And over time, the oil moves up toward the surface of the earth through cracks and holes in the porous rock until it reaches a non-porous rock deposit. And the non-porous rock, remember, it won't allow the oil to continue moving. So the oil becomes trapped under the non-porous rock deposit. Now, think for a moment. While oil was forming and moving, the earth was also undergoing changes. In fact, there were enormous movements of the crust as the center began to cool. When folding happened, it was like the earth fell back onto itself, and when faulting happened, it was, one layer was forced by rocks above down through the layers below. So you can see that the repositioning of porous and non-porous rock, this repositioning would have affected the movement of oil. When the earth shifted, cracks would have been opened and non-porous layers would have been dropped over channels that had previously been used as pathways for the transfer of oil and gas to the surface. Okay, as geologists, we're interested in locating the traps. Now, why would that be so? Because that's where we'll find the oil and gas reserves, and that's what I really want to talk about today. So there are several different types of traps, but today we're going to talk about the three most common ones: the anticline trap, the salt dome trap, and the fault trap. Look at this diagram. Here's an example of an anticline. As you can see, the oil's trapped under a formation of rock that resembles an arch. That's because the arch was bent from a previously flat formation by uplifting. In this anticline, the petroleum's trapped under a formation of non-porous rock with a gas deposit directly over it. This is fairly typical of an anticline. Because gas isn't as dense as oil, it rises above it. The dome over the top can be rock, as in this example, or it could be a layer of clay. The important thing is that the cap of non-porous material won't let the oil or gas pass upwards or sideways around it. Now let's look at a diagram of a salt dome. This salt dome shows how a cylinder-shaped salt deposit has pushed up through a layer of sedimentary rocks, causing them to arch and fracture. The oil deposits have collected along the sides of the salt dome. Salt's a unique substance. With enough heat and pressure on it, the salt will slowly flow, kind of like a glacier. But unlike glaciers, salt that's buried below the surface of the earth can move upward until it reaches the earth's surface, where it's then dissolved by groundwater or rain. Well, to get all the way to the earth's surface, salt has to lift and break through many layers of rock. And that's what ultimately creates the salt dome. Finally, I want to show you a fault trap. Fault traps are formed by the movement of rock along a fault line. This diagram represents a fracture in the earth that's shifted a non-porous rock formation on top of a porous formation. In this case, the reservoir rock, which is porous, has moved opposite a layer of non-porous rock. The non-porous rock prevents the oil from escaping. Remember, as in all traps, the oil's collected in the porous rock and trapped underground by the non-porous rock. Geologists study the terrain for indications of possible oil traps. For example, a bulge in a flat surface may signal the presence of a salt dome. Your textbook has a good explanation of how technology assists us in this effort, so I want you to read Chapter 3 before class next time.
29. What is the lecture mainly about? "30. Why does the professor begin by talking about the process that transforms organic material into oil and gas? 31. Listen again to part of the lecture and then answer the following question.
Okay, as geologists, we're interested in locating the traps. Now, why would that be so? Because that's where we'll find the oil and gas reserves.
Why does the professor say this?
Now, why would that be so?
"32. Select the diagram of the anticline trap that was described in the lecture. Click on the correct diagram. "33. Identify the non-porous rock in the diagram. Click on the correct letter. "34. According to the professor, what do geologists look for when they are trying to locate a salt dome?
Listening 7. Library.
Listen to part of a conversation between a student and a librarian.
Hi, how can I help you?
Hi, I'm looking for some material on reserve for Business 210.
Okay. Well, who's the professor? You see, we keep the files under the professor's name because there are a couple of sections, and the requirements are a little different.
Oh, okay. It's, Dr. Parsons.
Parsons? I don't see any books.
I think it's a DVD.
Oh, yes, here it is. Oh, wait, actually, there are 2 of them. But that's all right. Now, all I need's your student ID.
No problem.
There you go. Now, these will be due back at the desk in 2 hours.
2 hours? But that won't even give me time to go home.
Oh, you can't leave the library with reserved materials. You have to use them here. But we have some DVD players in the booths behind the reference section. I think there are several free now.
But I have to take notes and, I don't think I can get everything done in 2 hours.
Well, you can't take materials out again until someone else has used them, because the professor only left 1 copy of each. Sorry. Look, maybe 2 hours will be enough.
I don't think so. These are case studies and we're supposed to be able to discuss them.
Oh, I see. Well, when do you have class?
Tomorrow morning. I know I should have come in earlier, but this isn't my only class. I had an exam earlier today and I was just waiting to get that out of the way.
I see. Well, look, why don't
Isn't
you...
there any way to get an exception to the policy?
I'm afraid not.
Oh. Okay, then. Let me just check out one of the DVDs. That way, if I finish it, I can check out the other one for 2 hours, right?
Sure, that's perfectly fine. And here's a thought. I don't know if it will work for you since you have a morning class, but if you check out reserved material less than 2 hours before the library closes, then you can have it overnight.
Overnight?
Yes, but you have to have it back when the library opens the next day, and...
But I could do that. Oh, I'm sorry. You were going to say.
Well, if you don't return the material to the reserve desk when the library opens, then there's a $10 fine for the first hour and a $5 fine for every hour after that. That it's late, I mean. The usual fee's $1 for every hour, but when it's an overnight...
Ouch.
Yeah, it's a stiff fine because we need students to take the privilege seriously. Otherwise, other students who need to use the reserve materials wouldn't have access to them.
Oh, I understand.
And another thing. Sometimes more than one person's trying to use the overnight privilege, so sometimes when you wait until the end of the day...
Oh, and there isn't any way to put your name on a list or anything?
No, not really. It's first come, first served.
Okay. Then I think I'll go ahead and take the one DVD out now because I can still try to get the second one tonight, overnight. Can't I?
Sure. I'll tell you what. Come back a little before 9.
Okay. Will you be here? I mean, I'd rather come back to you.
I'll be here until the library closes.
Well then.
Do you still want to take out one of the DVDs?
Yeah, I might as well get one of them out of the way so I'll only have one left to watch.
Oh, wait a minute. Your ID.
Oh, I'm sorry. I thought I showed it to you.
You did, but I need to keep it here at the desk until you return the materials.
35. What does the man need from the librarian? "36. What is the man's problem? "37. Listen again to part of a conversation, and then answer the following question.
I don't know if it will work for you since you have a morning class, but if you check out reserve material less than 2 hours before the library closes, then you can have it overnight.
Overnight?
What does the man feel when he says this?
Overnight?
"38. What is the policy for materials on reserve? "39. What does the librarian imply when she tells the man to return at 9 o'clock?
Listening 8. Literature class.
Listen to part of a lecture in a literature class.
Today, we'll discuss transcendentalism. Transcendentalism, which is a philosophical and literary movement that developed in New England in the early 19th century. Transcendentalism began with the formation in 1836 of the Transcendental Club in Boston, Massachusetts, by a group of artists and writers. There's evidence that the group was involved in somewhat of a protest against the intellectual climate of Harvard. Interestingly enough, many of the Transcendentalists were actually Harvard educated, but they never met in Cambridge. Remember, at this time, Harvard had only 11 professors, and at least 11 members could be expected to attend a meeting of the Transcendental Club. So, their intellectual community was large enough to rival the Harvard faculty. All right, then. Their criticism of Harvard was that the professors were too conservative and old-fashioned, which, come to think of it, isn't an unusual attitude for students when they talk about their professors. But in fairness, the classroom method of recitation that was popular at Harvard required the repetition of a lesson without any operational understanding of it. In contrast, the Transcendentalists considered themselves modern and liberal because they preferred a more operational approach to education. Bronson Alcott translated Transcendentalism into pedagogy by encouraging the students to think, using dialogues and journals to develop and record their ideas. Language was viewed as the connection between the individual and society. In 1834, Alcott established the Temple School near Boston Commons, and later founded a form of adult education, which he referred to as conversation. This was really a process whereby the give and take in a conversation became more important than the doctrine that a teacher might have been inclined to pass on to students, an approach that stood in diametric opposition to the tradition at Harvard that encouraged students to memorize their lessons. The Transcendental group also advanced a reaction against the rigid Puritanism of the period, especially insofar as it emphasized society at the expense of the individual. The Puritans, I mean. According to the Transcendentalists, the justification of all social organizations is the improvement of the individual. So, in the literature of the time, the Transcendentalists insisted that it was basic human nature to engage in self-expression, and many interpreted this as encouragement for them to write essays and other opinion pieces. One of the most distinguished members of the club was Ralph Waldo Emerson, who served as editor of the Transcendentalists' literary magazine, The Dial. His writing stressed the importance of the individual. In one of his best-known essays, Self-Reliance, he appealed to intuition as a source of ethics, asserting that people should be the judge of their own actions without the rigid restrictions of society. You can imagine the reaction of the church, in particular the Unitarian Church, in which many of the intellectuals held membership. If individuals were responsible for their own code of ethics, then the clergy and the entire church organization was threatened. Perhaps because they were encouraged to think for themselves, the Transcendentalists came up with several options for living out their philosophies. Many were devoted to the idea of a utopian society, or at least to a pastoral retreat without class distinctions, where everyone would be responsible for tending the gardens and maintaining the buildings, preparing the food, and so forth. And quite a few were involved in some sort of communal living. Brook Farm was probably the most successful of these cooperatives, although it lasted only 6 years. Brook Farm and some of the other experimental communities brought to the surface the problem that the Transcendentalists faced when they tried to reconcile a cooperative society and individual freedom. Both Emerson and Thoreau declined to participate in Brook Farm because they maintained that improvement had to begin with an individual, not a group. From 1841 to 1843, Emerson and Thoreau lived and worked together in Emerson's home, exchanging ideas, developing their philosophies, and writing. Upon leaving Emerson's home, Thoreau built a small cabin along the shores of Walden Pond near Concord, Massachusetts, where he lived alone for 2 years, devoting himself to the study of nature and to writing. He published an account of his experiences in Walden, a book that's generally acknowledged as the most original and sincere contribution to literature by the Transcendentalists. But I'm getting ahead of myself. Transcendentalism didn't change the educational system, and it certainly didn't reform the church in any significant way, but it did, in a sense, change the direction of American social and political culture, because Transcendentalism evolved from its initial literary roots into a force that shaped the way a democratic society was interpreted on the North American continent.
40. What does this lecturer mainly discuss? (41) Listen again to part of the lecture and then answer the following question.
All right, then. Their criticism of Harvard was that the professors were too conservative and old-fashioned, which, come to think of it, isn't an unusual attitude for students when they talk about their professors.
Why does the professor say this?
Which, come to think of it, isn't an unusual attitude for students when they talk about their professors.
42. According to the professor, what was true about the Puritans? (43) Why did the Church oppose the Transcendental movement? (44) Why did the professor mention Walden? (45) According to the professor, what was the most lasting contribution of Transcendentalism?
Listening 9. General Science Class.
Listen to part of a discussion in a general science class.
Okay, this is a general science course, and as such, the first thing I want you to understand is the scientific method. In your book, the definition of the scientific method is an organized approach to explaining observed facts with a model of nature that must be tested and then modified or discarded if it fails to pass the tests. So, let's take that apart and talk about it. What are observed facts? Anyone?
I'll try.
Okay.
Isn't a fact supposed to be a statement that everyone agrees on?
So you'd say that a fact is objectively true.
Yeah, that's what I mean.
Okay, that sounds good. But what about this? We consider it a fact that the sun rises each morning and the earth rotates. But facts like that aren't always agreed upon. Look, when we say that the sun rises each morning, we assume that that's the same sun day after day, an idea that might not have been accepted by ancient Egyptians, whose mythology taught them that the sun died with every sunset and was reborn with every sunrise. Now, let's consider the case of the Earth's rotation. Well, for most of human history, the Earth was assumed to be stationary at the center of the universe. So, as you can see, our interpretations of facts often are based on beliefs about the world that others might not share. Still, facts are the raw material that scientific models seek to explain, so it's important that scientists agree on the facts. How can we do that?
How about this? A fact has to be verified. I mean, that's where the testing comes in. So we have to be able to test a model, but we have to be able to test a fact too, right?
Now you're on the right track. In the context of science, a fact must therefore be something that anyone can verify for himself or herself, at least in principle. So, even though the interpretation may be different, some interpretation of the sun is there every morning, and that can be verified. Then a model's proposed to explain the facts. And a model is?
An explanation of the facts.
Right. Once the facts have been observed, a model can be proposed to explain them and not only explain what's obvious, but also make predictions that can be tested through further observations or experiments. Let's go back to Ptolemy's model of the universe, which assumed that the Earth was the center of everything. Okay, that was a useful model because it predicted future locations of the sun, moon, and planets in the sky. However, although the Ptolemaic model remained in use for nearly 1,500 years, eventually it became clear that its predictions didn't quite match actual observations, a key reason why the Earth-centered model of the universe finally was discarded.
So models are discarded when they don't match the observations.
Exactly, and new models are proposed to explain the facts in a better or more inclusive way. Okay, how does a model achieve the status of a theory?
Well, I guess sometimes the model doesn't fail. You know, it gets repeated by many experiments, and the predictions are verified.
So when a prediction's verified, repeated, then we start to assume that the model's a valid representation of nature. And when that happens, with many experiments and a number of different researchers, then the model achieves the status of a scientific theory.
But...
Yes, Jerry?
Well, the problem is that theories get discarded too, don't they?
Absolutely, because it isn't really possible to prove that a theory is true beyond all shadow of a doubt. And that's good because doubt is a cornerstone of science. Even a well-researched and presented theory should undergo continuous challenges from the scientific community with further observations and experiments.
I'm sorry. Did we mention the term hypothesis? Does that fit in with a model or a theory?
Glad you brought that up. A proposed model is often called a hypothesis, and that just means that the scientist is making an educated guess that the model's predictions will bear up under testing.
So a hypothesis is a proposed model.
Right. But let's put this all together, shall we? Step 1's observation, the collection of data, that is, observations. Step 2's hypothesis, or a model to explain the facts and to make predictions. Step 3's additional observations and experiments. And here's the important part. When the predictions fail, then we recognize that the model's flawed, and we have to revise or discard it. But when the predictions are verified on a consistent basis, then we consider the possibility that we have a true representation of nature, and we elevate the model to the status of a theory.
So step 4 is the theory?
Right. But even then, the theory must undergo step 5. That's further observations, experiments, and challenges. Okay so far? Okay. Now for a reality check. In the real world of science, discoveries are rarely made by a process as mechanical as the idealized scientific method outlined in your textbook, the one that we just summarized. For example, anyone recognize the name Johannes Kepler?
Sure. Didn't he propose the laws of planetary motion?
He did, in about 1600. But instead of verifying new predictions on the basis of his model, he tested the model against observations that had been made previously. And like most scientific discoveries, Kepler's work involved intuition, collaboration with others, moments of insight, and luck. And eventually, other scientists made a lot of observations to verify the planetary positions predicted by his model.
Go ahead.
So the scientific method in the book, that's not really the way it happens a lot of the time?
Okay, let's put it this way. The scientific method's a process that we need to keep in mind as we do the work of scientists. But we should also understand that it's an idealized process for making objective judgments about whether a proposed model of nature's close to the truth. And we should also keep in mind that in the work of scientists, other factors are also brought to bear on those ideal steps in the process.
46. What is this discussion mainly about? (47) Why did the professor give the example of the ancient Egyptians? (48) Listen again to part of the discussion, and then answer the following question.
So a hypothesis is a proposed model.
Right. But let's put this all together, shall we?
Why did the professor say this?
But let's put this all together, shall we?
(49) According to the professor, what did Kepler do to verify his theory of planetary motion? (50) What can be concluded from information in this discussion? (51) What technique does the professor use to explain the practical application of the scientific method?